Hello there, ladies and gentlemen. My name is Jonathan, and today I will be teaching you all the physics that go into shooting a tennis ball with a hockey stick. So, in order to explain the physics that go into shooting a ball with a hockey stick, I'll be explaining different concepts I have learned over the first 3 physics units to assist in the explanation. For Unit 1, the concept that best resonates with this activity is projectile motion. So in order to understand what projectile motion is, we need to understand what a projectile is. So a projectile is an object that is launched from the surface of the earth. In my activity's case, it is my tennis ball. So projectiles are not self-propelled, so they have to have some other external force acting on them. In my case, it's a hockey stick. And projectiles can also be launched horizontally or at angles to the surface of the earth. In my case, it was launched horizontally and it was launched at an angle, although it was pretty tough to see the angle. Projectile motion is when an object is launched near the Earth's surface and it moves in a curved path. There are 3 types of projectile motion: horizontally launched, launched from the ground at an angle, as well as launched at an angle from some height. So the type of projectile motion that my activity falls under is the second type, launched from the ground at an angle. This type of projectile motion results in the object's y-level displacement being 0 due to the fact the final resting place is at the same height as the original starting place. This type of projectile motion also takes into account the angle the object was launched from. As you can see in the video, when I was shooting the ball, there is an angle of about 35 to 40 degrees from which the ball goes upwards. This type of projectile motion can be represented by the following equations. One of the equations is for horizontal distance, and one of the equations is for time. So moving on, now I will be explaining this activity using concepts learned in Unit 2. So my 2 biggest takeaways from Unit 2 are Newton's 3 laws of motion and free body diagrams. So let's start with free body diagrams. So a free body diagram is some sort of illustration used to visualize all the applied forces acting on an object at a given moment. So this is the free body diagram of the ball after getting hit by the stick. So there's an applied force as well as some sort of angle, as we discussed earlier, and there's also force of gravity. So typically, if the ball was on the ground, there would be some sort of normal force acting on it, or to coexist the force of gravity. However, due to the fact that the ball is in the air, there is no normal force. Also labeled on the free body diagram is the weight in grams of the ball. Now I will be talking about Newton's 3 laws, starting off with Newton's first law. So Newton's first law states that an object remains at rest or moves at a constant velocity unless acted upon by an external force. In my activity's case, the tennis ball was at rest until an external force, in this case the hockey stick, made contact with it, which resulted in its acceleration. So Newton's second law states that mass multiplied by acceleration is equal to total force, and mass affects acceleration. So this basically means that an object with greater mass will have less acceleration, and in my activity's case, the tennis ball doesn't have that great of a mass, so it will have a pretty large acceleration. So Newton's third law states that when one object exerts a force on another, an equal opposite force is exerted on the object. So technically the tennis ball did exert a force backwards on the hockey stick. However, the stick has too much mass to actually be affected and for you to realize it. That brings us to the third and final unit. In this unit, the most prominent thing we learned was work and power. I will now explain how this relates to my activity. So let's start off with work. Work is the process of transferring energy from one form to another, and it's modeled by the equation W equals F delta T, where F is force in newtons and D is total displacement in meters. In my activity, I'm transferring force from my arms to the hockey stick in order to propel it forward in order to hit the ball. Overall, there isn't really much work in this scenario, however, it is still present in small amounts. Next up is power. Power is the rate at which work is done. The equation for power is P equals W delta T, where W represents work, delta T is time, and P is power measured in watts. Essentially, to find power, you need to calculate the work I do, and then find the amount of time it takes for me to hit the ball after starting my shooting motion, and then dividing work by the amount of time it takes for me to start and finish my motion. I hope this video helps you fully understand all the physics that go on when shooting a tennis ball with a hockey stick, as there's much more than what you can see with the naked eye. Overall, thanks for watching, and bye-bye.